Naming ionic compounds. Okay. So to first off, when we name something, we read from left to right, yeah? We're going to name it from left to right. So what part of the ionic compound is written first? Do you remember from last time? Cation or anion?
Cation.
Cation first. So let me show you how to name cations. And there's a few different types of cations. So the first type are the main group elements, or main group cations. And we just name them with the element name. For example, Na plus is called what? Sodium. The name of Na is sodium. So this is the sodium ion. Good? For transition metals, sorry, no, not transitions. So let's do polyatomic ions first. Or polyatomic cations. We just use the polyatomic ion name. So, for example, we only have one. This is called the ammonium ion. Good? And one other type of cation are transition metal cations. And to name these, we use element name with charge written as a Roman numeral in parentheses. A lot of info without examples, right? We'll give a little bit of example there. So if we have, let's say, Fe3 plus, for example, it's going to be called iron. That's the element name. Roman numeral 3 in parentheses. And we call it iron 3. Good? Do we need to go over Roman numerals, guys? Maybe a little bit? Okay. Some of us probably have it down. Am I going too fast? Okay. 1 is I, 2 is I, 3 is I, 4 is 1B45 or IV, and 5 is V. Good. 6 is VI, 7 is VII, 8 is VIII, 9 is 1 before 10 or IX, and 10 is X. And we don't need to know more than that. And that's plenty. We probably won't, use more than 8, but whatever. Good? All right, let's go to section 6 on our worksheet from last time. Does anybody need one from last time?
Thank you, sir.
Any questions so far? Kind of a lot of info, but all right, here we go. Let's practice. Okay, we already did that one. Let's do NH4 plus. Oh, we did that one too. Right? Okay. Let's do, what's that one called? Did anybody get these down yet? If you don't have these down, let's get them down. Memorize these. Yeah? Get all the polyatomic ions. There's only 20 of them, 20-something, right? 21. Okay. So that's the ammonium ion. What about Ni2 plus? What do we call that ion? First of all, what kind of metal is it?
Nickel?
It is nickel, but what kind is it? Is it a main group element or a transition element?
Oh, it looks like if it's on transition.
Yeah, you're going to have to, do you have to memorize where these are? No, you have to look on the periodic table and find them and know which ones are transition, right? So this is a transition metal, so we need a Roman numeral to represent the charge. So what's this called? Nickel, Roman numeral 2. Simple enough? How you feeling? Okay. What about, let's write the chemical formula for iron 1. What's the symbol for iron? Fe. 1 plus or just plus? Yep. Either one. So generally it's written without the 1, but I don't care if you write the 1. Oh, what else? What about aluminum? What is the cation formula for aluminum? Use your periodic table. What kind of metal is aluminum? Main group or transition? Main group. So we don't need Roman numeral here. It's just Al with what charge? You have to know. 3 plus. You have to memorize that? No, you have to know how to use your periodic table. Does everybody know how to use your periodic table here? If you don't, let me know right now before we get too deep. Okay? All right, let's talk about naming anions, unless you have any other questions on section 6. You want to do any other ones? Okay. Naming anions. We have 2 different groups here. We have the main group anions, which is like, so what we do is we use the element name and then change the ending to IDE. So for example, we got Cl minus. What do we call this? You've probably heard it before. Chloride. So it's chlorine is the element name. We change the ending to IDE. Chloride. Good? And a few examples in section 7. What about H minus? What's that called? Let's call it H plus. Let's call it H minus. Okay, yeah, sometimes it is H minus, but most times it's H plus. Okay, what is this called? Yeah, that's hydrogide. We keep it simple. Lower number of syllables, hydride. So hydrogen. Change the ending to IDE, hydride. Try to keep the syllables down so it's not too clunky. Good? And, all right, so what about, next type of anion are polyatomic ions. Any ideas how we name these? Just the polyatomic ion name, that's it. Just like cations, right? Polyatomic ion name. So SO42 minus is called, we know that yet? If we don't, here's your second warning.
Is it sulfite?
Sulfite. Yeah, sulfate, actually. SO42 minus.
Sulfite would be
SO32 minus, yep, you got it. Good? So get those down. Promise it's going to make your life easy if you have it. Sorry, sulfate. It's not called SO42 minus, all right. And that's it. That's how you name ionic compounds. Except for you just put them together, right? So let me give you a little summary of all this. So we have different types of elements. We have main group elements. We have transition metals. And we have polyatomics. So the cation, the anion, main group, use element name. Anion, we change the ending to IDE. Transition metal cation, we use the element name with the Roman numeral, for example, that represents the charge. Good? For the anion, we won't have transition metals as the anion. So we don't have to worry about that one. Polyatomic ion, I'm going to erase this center line here. And we just use the polyatomic ion name. For both cation and anion. Good? All right, let's practice some of these. So section 8. Any questions up to this point? I feel like I'm hauling through this stuff. You guys feel that way, or do you feel okay? Okay. All right, let's do do anybody need this chart still? Okay. Yeah.
Thank you.
So let's do AL2O3. This is on your worksheet, section 8. Well, maybe I ought to give you some steps to writing the name, yeah? Would that help? Okay. Step 1. Determine type of compound. What are the two types of compounds we're going to learn? Ionic and, we didn't learn the next one yet, covalent. Okay? How do you know if it's an ionic? We talked about last time. Simple way to tell is, if there's a metal in it, it's an ionic compound. That's true. If there is a metal, it will be an ionic compound. But the real answer is if it's made of ions. So if it has a polyatomic ion, it's an ionic compound. If it has a metal, it's an ionic compound. Good? If it doesn't have a metal and it doesn't have an ion, then it's a covalent compound. So why is that the first step? Because we name covalent compounds differently. And later on, we're going to learn how to name covalent compounds, and that's going to be the freshest on your mind. And then I'm going to throw an ionic compound at you, and you're going to name it like we name covalent compounds, and it's going to be wrong. So make sure that's our first step. Good?
So it's like metal for ionic compound, and then the other two are, sorry, I know it's an ion.
So if it has an ion in it, so if it has a polyatomic ion in it, it is also an ionic compound. And that's why you got to know your polyatomic ions. Okay, you got to just have them down. Unless you want to put that on your little card for the rest of the semester, but we're going to have other things, right? So get them down is my suggestion to you. Okay, step 2. Write cation first and anion second. We'll write the name of the cation first and then the name of the anion second. That's it. Good enough? Well, there might be a little to name the cation, you have to know what kind of metal it is, right? So you know if to name it with the transition, with the Roman numeral, okay? So just make sure you watch that. All right, so what's the name of this compound? Al2O3. What kind of, so is it an ionic compound or covalent compound? How do we know it's ionic? Yeah, aluminum is a metal, Al, right? And if you, do you have to memorize that? No, look at the periodic table. Find it and see where it is. See what type of element it is. We have to know whether it's a metal, non-metal, or metalloid, right? Yeah.
How do you know
Sandy.
aluminum is a metal?
A couple ways. Well, let's just do one. Okay? We know it's a metal because it's on the left of the metalloid staircase. Do you remember that? All of those are metals, except for hydrogen is not a metal. Good? So this is aluminum. Do we need a transit? Is this a transition metal? No. So we're just going to call the cation by its element name, aluminum, aluminium. And then the anion second. What's this anion called? Oxygen is a main group element. Oh, did we? Yeah, so we changed the ending to IDE, right? Aluminum oxide. Done. Good? Okay, let's do Fe2O3. Common name is called rust. But let's find the chemical name.
It's iron oxide.
Is it iron oxide? Is it iron 2 oxide? Or is it iron oxide?
It's
Or is
iron
it
two
something
oxide.
different?
So you got, it's a transition metal, so you're gonna have the Roman.
Oh, it is a transition metal. So is the Roman numeral 2? It's not. Remember how we figure out the charge from last time? Remember doing this?
So it's F3.
So this is 2 minus. There's 3 of them, so that's a total charge of -6. This side has to be +6. Are we remembering this, guys? Yes or no? Okay. And there's 2 irons, and they're identical. They're both irons. So +6 divided by 2 is +3 or 3+. So that means it's iron 3 oxide. This is why we learned how to figure out the charge, so that we can write that Roman numeral correctly. Good?
That way, that's kind of confusing. The crisscross way you do it.
Okay. It is easier if you don't have to multiply anything.
Yeah.
Okay? How you gonna know? Let's do FeO. Name that one. Everybody do this one on your own. See if you can do this.
It's iron oxide.
Is it a transition metal? Then it's not iron oxide. Has a Roman numeral. How are we feeling, guys? You want to tell me what it's called? Iron 6 oxide? Everybody get iron 6 oxide? Hey, what'd you get?
I only put iron oxide, but how did you find 6?
That's a great question.
Okay,
Let's do this. What's the charge of oxygen? We have to know oxygen's charge before we can do this. What is it? 2 minus. Does everybody understand how we got that? Okay? And how many oxygens are there? 1, so that's a total of -2. You with me? The other side has to be what to cancel out the -2? +2. And how many irons are there? Just 1, so it takes all of the charge to plus. Are we good? So we have iron what? Roman numeral 2 oxide. Does that make sense to everybody? So if we try crossing these numbers up, that's a 1 and that's a 1. Is this iron 1 oxide? No, because 2 is the charge of oxygen, not 1. That's why we have to multiply everything by 2 if we do it that way, right? So I don't care if you do it that way, guys.
Well, so my question is like, whenever you have the transition metal, sometimes it just takes on the charge of the compound it's connecting with. So it's like, it could have been iron nitrogen, and it just would have been iron 3 nitrogen.
Well, it all depends. It all depends. If this is Fe3N, then it's iron 1 nitride. But if it's Fe3N2, then it's iron 2 nitride. Right? But if it's Fen, then it's iron 3 nitride.
Yeah, so if it
You've-
only has 1.
It doesn't matter. I wouldn't say if it has 1, then it's the same. I wouldn't try to do that. It's trying to remember too many things. Well, I wouldn't do it. I'm not saying you can't do it. I'm just saying I wouldn't. I would have one method that works on everything. That's why I do it this way. But that's me, guys. I know I've been only doing this for 15 years, but that's me. No, I'm serious. You don't have to like it the way I like it. You don't. You can cross them up, you can. You just have to remember to multiply them if it's not correct. That's it. People probably do it that way. And it works for them. That's fine. Good?
Gotcha.
Sorry, I didn't mean to say do it my way or the highway.
I get it.
Question, somebody had their hand up? Yeah, Carla.
So, like, for example, when you did the aluminum oxide, we didn't use this method because it wasn't a transition.
That's right.
Okay.
Because we know the charge of aluminum is always 3 plus. And so we don't need to write it as aluminum 3 because it's always going to be 3.
Okay.
Does that make sense?
Yeah.
And
I was
for
just confused because
no.
I thought that now we're gonna have to like cross everyone,
yeah.
but that makes sense.
you only have to do it if you don't know what the charge is. For the transition metals, we don't know.
Okay. Thank you.
Great question. I love that. Are we good? You want to try some more? Okay. Someone say no. It's always okay. Let's do. Let's do TiO2. Try it. So first step, what kind of compound is this? Ti is titanium. We know that's a metal because it's in the metal group. What kind of metal is it?
Transition.
Transition, that means we need a Roman numeral. We better find the charge. You see the process? What's the charge of oxygen, everybody?
2
Or
negative.
should I give you some time? Who needs more time? Need more time? Okay, it's 2 minus. So what's the total charge of all the anions?
2.
There's 2 of them, so what's the total charge? -4. Good. Are we good, everybody, there? We good on that step?
So you just got -4 because you added,
No, I didn't add, I multiplied.
oh, okay.
Why? Because there's -2 2 times. You with me?
Yeah.
Okay, so that's -4. And this is an ionic compound because it has a metal in it, and all ionic compounds are neutral. So the other side has to be the opposite of -4, which is +4. Always the opposite. Are we good? How many titanium ions are there? There's only 1 because there's not a number there, right? So it takes all 4. So what's the name of this compound? Titanium, Roman numeral 4, oxide. Good? How are we feeling? Yeah.
Sorry, I got confused when you said, that titanium takes all 4. What do you mean by that?
Okay. So in this one over here, great question. In this one over here, there was 2 irons there. Do you see that? And so we have to take the +6 and divide it into 2 equal pieces. So 6 divided by 2 is +3. Hence we got +3 there. Good? But here, there is no number right there. That means we have how many? 1, right? So that means we have to take 4 and divide it into 1. Well, that means we're not dividing it. It's just all of it. And that's why I said it takes all of it. Does that make sense? Great question. Sometimes I say words that... Perfect. Thanks for asking. Any other questions? Okay. Do you want to try any more in section 8?
Yeah, when was the parentheses?
Yep, let's do it. So you got Na parenthesis CH3CO2 parenthesis 2. Is that right? No, Ni. Ni. I said, well, there shouldn't be a 2 there. Okay. Okay. Do we need to figure out the charge of this one? How do we know? Is this a transition metal? Yes, nickel is a transition metal, so we have to figure out the charge. That means we have to know the charge of the anion. What is this anion?
Acetate.
Acetate, yeah. We have to know that. This is acetate, and what's the charge of acetate? We have to know this. It's a 1- charge or a minus charge, right? How many acetates are there? 2 of them. So we have a total charge of what? -2, yeah. And so the other side has to be a total charge of +2. Good, we're getting this. And how many nickels are there? Just 1. So he takes the whole charge, right? So what's this called? Nickel, Roman numeral 2, acetate. That's the name of the cation, that's the name of the anion. Hook it together, we got it. Good? Questions?
I have a question.
Yeah.
Where did the -1 on top of acetate come from?
It comes from knowing that acetate is a 1- charge.
Oh, right.
Yep, you gotta know it. It's one of those part of the polyatomic ion, you just have to know it. So we're not gonna go into the details of why it is, but you just have to know it. Okay? So memorize these. That's going to make your life much, much easier in this class. If you don't memorize it, you're going to struggle the rest of the semester. Good? Get these down. Memorize them. Any other questions, or you want to go over other ones on this, section 8? Okay, moving on. Okay, now we've got to name these. In fact, or not name them, write the chemical formulas. But we already went through this, didn't we? Last time? Okay, let's try some of these. Just make sure we got this. Rubidium sulfide. Okay? Writing the chemical formula, what do we write first? The cation or the anion? Cation. We always do the cation first. And it's rubidium. Is this a metal or a non-metal? It's a metal, good. That's how we know it's an ionic compound. So what's the charge of rubidium? What is it? Yeah, you have to find it. It's in group 1, so it's 1 plus, or just plus. Good? Does everybody see rubidium on the periodic table?
Yeah.
Okay. I don't remember what number it is. It's right below potassium or something? Okay. And then sulfide, what kind of anion is this? Main group or polyatomic ion? Sulfide. It ends in IDE. That means it's what kind? Main group. There are a few polyatomic ions that end in IDE, like hydroxide, hydro, oxy. You see there's 2 of them. That's not a single element. That's a polyatomic ion. And cyanide. Well, cyanide is carbon and nitrogen. 2 different ones. So you just got to know those. But this is sulfide, so it's sulfur with the 2 minus charge. You with me? We all understand why 2 minus? Because it's in group 6. It has 2 less than the nearest noble gas. Good. Now what do we do? We do what? We have the charges right here. Because rubidium is in group 1. They're both main group elements. So we should just look at the periodic table and know what these charges are. Do we know how to do that? Okay. So we know the charge. What do we do with these charges? We cross them. Bring this 2 down here, this 1 down here, and we got RB2S. We don't need to write the 1. And then we got to make sure we do what to it? Simplify that ratio. Is that simplified? Yes, so we're good. Good? Okay. What about, let's see. Let's try iron 3 sulfate. You want to try this one on your own or do it together?
Let's try it on real quick.
Okay, try it. Connor? You want to take a picture of that, or
Yes, please.
right? You got to know those.
And those are the ones we gotta study.
Yeah.
Is it just those?
Mhm.
Or is there more?
I think there's one more actually. It's perchlorate. Gotta write that one down. Which is ClO4 minus.
ClO.
C, capital C, lowercase l, O, capital O before the 4,
Gotcha.
and then 4. That was the minus charge.
And then what was that called?
Perchlorate.
Thank you.
Hmm? Here's the answer if you have it. You want to check? How are we feeling? Do we need to go through this one? Okay. So this is a transition metal because it has a Roman numeral, so we know its charge. So in a way that makes it easier, right? We don't even have to look. It's just Fe3+. We have to know what the symbol for iron is. But after a while, we'll get that because we use that one a lot. And sulfate, is this a main group element or polyatomic ion? It ends in ate or ite. It's a polyatomic ion. Okay? So this is SO4 2 minus, and we got to just know this, guys. Got to just know them. And I know if you didn't know them the first of class, you still don't know them, so I get that. Okay, I'm just trying to get it into you. Make sure you get these down. Okay. All right, now what do? We've got the charges. We cross the charges. So Fe2 parenthesis SO4. Why do we put parentheses? There's more than one, right? There's 3 of them. If there's only one, we don't need to put the parentheses. If you put the parentheses, it's not going to hurt anything. Just like if we write 3x plus 2, is that the same as 3x plus 2 outside of parentheses? Yeah, they're the same. Doesn't matter. You just won't see it. Like if we have NaOH, you won't ever see it like that. It'll always be NaOH. But okay. Your tests are multiple choice. If you want to always write parentheses for polyatomic ions, no problem. Okay? Any questions? Okay, do you want to go over any other one of those on section 9? We good? I'm going to do one more. Got to name this. This is a naming one. Just to make sure we got it.
Excuse me. Thank you.
So what kind of metal do we have? It is copper. What kind of metal is this? Transition metal. So we got to figure out the charge. What's the charge of SO4?
2 minus
2 minus. And how many are there?
4.
1. How do we know there's 1? No parentheses. It's a polyatomic ion and 4 is part of it.
Gotcha.
but there's no parentheses. I bring this one up because it's a common mistake people make. So they say, okay, this is a -8 charge, but it's not. There's only one, so that's a -2 charge. This side has to be +2. There's only one, so it's a 2+. So what's this called? Copper 2 sulfate. Good? Yeah, Sandy.
How did you get the -2 in the bottom?
Okay.
Right?
So see how there's no parenthesis right here? Whoops. See how there's no parenthesis right here? If there's no parenthesis on a polyatomic ion, that means there's how many of them? Only one of them. And it has a -2 charge, because we have to know that. Good? So -2 times 1 is -2. Are we good? All right. If there's not any question on ionic compounds, we're going to move to covalent. So tell me, what do you need? Yeah.
So,
Remind me your name again?
Carmina.
Armina, that's right. Okay.
So, I'm not gonna scare you, but all these lectures, I can go back and like
Yeah.
watch them. Right?
If I upload them and send you links to them, like I did on all of the other ones, I didn't the last few times. I will do that.
Yeah, if you can, 'cause I'm like
Yes.
lost.
Yes. Will you send me email reminding me? Because I get home, it's late, and I don't want to do it at night.
I'll send it to you right now in the discussion. Should I put it in the discussion?
Sounds good.
Okay.
Yep.
Thank you so much.
Yeah. Anything else? Sorry, I meant to do that because sometimes you miss and you need to watch it anyway. Okay, so. But if it, I'm going to try to stay on top of things, guys, I promise. But if I don't, can you find lecture videos on Canvas? Yes. And eventually I'm going to put mine there, but I don't, I'm making them right now, right? This is my first time making the videos, full set, okay? But right now there's another professor's videos on Canvas you can watch. But I will get these out, yes.
Okay.
Good? Any other questions? All right, let's move on to covalent compounds. All right, so covalent compounds are composed of nonmetals only. Okay. Remember we talked about ionic compounds always being neutral? Are covalent compounds always neutral? They are not. What's an example of a covalent compound not neutral? Polyatomic ions are covalent compounds. Why? Because there's no metals in them. Good? We also talked about ionic compounds being written as the lowest whole number ratio. Yeah? We don't do that for covalent. They're not always written as lowest whole number ratio. Sometimes they are, sometimes they're not. Okay? Doesn't make it harder. You just have to know. Don't simplify covalent compounds. Do not. Okay? What else? So we talked about ionic compounds being crystalline solids at room temperature. Covalent compounds, they're all over the place. They could be gas, they could be liquid, they could be solids. They could be crystalline, they don't have to be crystalline. They're just different, okay? We talked about ionic compounds being neutral, conductive when dissolved, right, or melted. Well, ionic or covalent compounds are not conductive, unless it's the ion. But if it has an ion, it's going to be with a metal. Okay. Good. So I didn't write anything there. Not always neutral. Not always. In fact, I'm just going to say not written. Whoa. As lowest whole number ratio. Okay. All right. And in ionic compounds, any questions on those? What makes it covalent? So when we look to find out, okay, when we name these, name ionic compounds or covalent compounds, first step is, what type of compound is this? How do you tell? If there's a metal in it, it's ionic. If there's no metal, it's covalent, except for one exception. If it has an ion in it, if it has a polyatomic ion in it, it is an ionic compound. So, for example, NH4OH. Is that ionic or covalent? There's no metals in it. But this is a cation, that's the anion. This is an ionic compound. How are you going to know those? If you get the polyatomic ions down, you'll know them. Okay? So, not covalent. All right, another thing on ionic compounds. What happened to the elements when they became, what happened to the electrons when an ionic compound was formed? Do you remember? They either, they either gain or lose electrons to have the noble gas configuration, right? Remember that? And they do that to get the octet. Is that right? So ionic compounds gain or lose electrons to reach the octet. Covalent compounds, on the other hand, they share electrons to achieve octet. What's that?
They're not conductive.
Yeah. Oh yeah, let's write that. Not conductive. Right, thanks. So they're kind of ionic compounds opposites, right? Okay. All right. Any questions about what makes it covalent versus ionic? Okay. Get those down. Make sure you can tell the difference between the two. Next, let's talk about Lewis structures. So these are also called electron dot structures. But we give it name Lewis structure because that's the guy who came up with it. Yeah, Connor.
I'm trying to remember, rewind. So, could a covalent compound be two metals because they're
No, they could not. If it's two metals and that's all it is, it's neither a covalent or ionic. What is it? It's an alloy. It's a mixture. Like steel is a mixture of metals, right? Brass is a mixture of metals. It's just a mixture. You can separate it physically.
So same thing, and then so if it has a metal and the poly,
And the polyatomic ion?
then it's an ionic bond, right?
Yeah, if it has a metal in it and a non-metal, it's an ionic. No exceptions.
Gotcha.
But if it's just polyatomic ions, or any ion for that matter, then it's ionic. But if it's no metals and no ions, yeah, it's covalent. Good? Great questions. All right, let's start simple. So the Lewis structure, we just worry about the valence electrons. Why is that? Because those are the only electrons that participate in the chemical reaction. The only electrons that change, okay? So if we do, let's say, lithium, how many valence electrons does lithium have? Look at your periodic table, tell me. Just one. So we're going to just draw one dot, yeah? That's the Lewis structure for lithium. Done. What is it for carbon? Try again. 4 valence electrons, right? Yeah. 1, 2, 3, 4. And how we do it is we put one dot on each side, because electrons don't like to pair up. Why not? Because they're the same charge and they repel, right? So we're going to put one dot on each side until we have more. What about oxygen? How many valence electrons does oxygen have? 6. 1, 2, 3, 4, 5, 6. And do I have to write the 2 dots on top and on the right? I could pick any side, doesn't matter. Okay? Nitrogen has 5. 1, 2, 3, 4, 5. Chlorine has 7. 1, 2, 3, 4, 5, 6, 7. And neon has 8. 2, 4, 6, 8. That pretty straightforward? Yeah, Sandy.
How do you determine the valence?
The valence electrons for transition metals?
Yeah.
Or just for any
For
element?
any, yeah.
Okay. Let's do a review here. Group 1, Group 1 has 1 valence electron. Group 2 has 2 valence electrons. Group 13 has 3 valence electrons. 14 has 4. 15 has 5. 16 has 6. 17 has 7. 18 has 8, except for helium only has 2. What about these guys? We can't tell. That's why we got to figure it out, right? We got to do this number and figure out the charge. So I will never ask you how many valence electrons a transition metal has. Okay?
Quick question.
Yeah.
So, back to the Lewis structure, so that's just basically what we've been doing, like, in that earlier, like, when we were, that's just what, because when we were writing, like, when we were doing the valence electron, that's how you were writing everything down.
Yeah.
That's
That's it.
that's the name of it, okay.
Yep. So far.
Uh,
That's the simplest case. Just a single element. But that's just a single, that's kind of like one step to getting to the Lewis structure for the compound. Good? Anything else? All right. Now, Lewis structure is just one step of many that we're going to learn. So, it's like the first step for covalent compounds. Okay? So let's, any questions about the Lewis structure for just a single element? Okay? Yeah, Hunter.
You ever write like the inner shell, the two, which is has two electrons, or you just go to the valence? Just write the valence?
Just the valence electrons. Yep, that's it. Yep. Why is that? Is that those are the only ones that participate in the chemical reaction. Only ones that change. That's why we have a special name for them. Okay? All right. Before we continue on, let's talk about the diatomic molecules. Diatomic molecules. The word molecule means a covalent compound. Okay? What does the prefix di mean? Two, right? Yeah. Two atoms, atomic, right? Two atoms of the same element. And there are 7 diatomic molecules. And you have to memorize these. All this memorization, right? I'll show you an easy way to remember. Diatomic molecules. Only 7 of them. You guys remember phone numbers? It's even easier than that because there's 7, not 10, right? Okay. Whatever. All right, here they are. Look at another periodic table here. Sorry, my pen died on me. Okay. It starts at number 7. Let me use a different color. Starts at number 7. Then we draw a 7. Sorry. That's kind of cool, right? Starts at 7. We draw 7. What's the bad thing about that? It's only 6. The 7th one is hydrogen, king of exceptions. Good? So we have H2, we have N2, O2, F2, Cl2, Br2, and I2. So in nature, these things don't exist all alone. These are the only 7 that do this. So when we breathe oxygen, we are breathing O2, not O. You with me? So you got to know those. For example, I might tell you methane might burn in oxygen, right, to produce carbon dioxide and water. And if I say that in words, eventually you might have to write the chemical formula. And you have to know that it's O2 and not O. If you write O, everything from then on is going to be wrong. So you got to know that. You don't have to know how to write this formula right now. We'll get there. Just saying as an example. Good? All right, we good with the diatomic molecules? Okay, let's go back to the Lewis structures.
Oh, no, for 1 second, sorry.
Yep, you want to take a picture? Do that.
Okay, I'm good now, sorry, I'll do that.
Okay.
Thank you.
Thanks for stopping me. Okay, now let's draw Lewis structures for the most simplest covalent compound, hydrogen gas. Let's write steps to do this. And we can even use these steps to write the ones for a single element, okay? But here they are. Step 1, we count the valence electrons. Valence electrons. You count this number, this is all you get to use. Can't use any more, any less. You got to use this number. If you count them incorrectly, everything on from here on out, remember this is the first step, is going to be wrong. So you got to know how to count valence electrons. Step 2, determine central atom. Central atom, usually it's by itself, like for example CO2. There's 1 carbon and 2 oxygens, right? So the carbon's going to be the central atom. Okay? But if it's hard to tell, it's going to be the least electronegative. Negative. And again, I'll be giving you this sheet on every exam, the electronegative chart, right? Do you remember that? Electronegativity? The ability to accept electrons during a chemical reaction. Okay? And a little note, it's never hydrogen. Well, yeah, never hydrogen. Why is that? For example, NH3, if hydrogen was the central atom, how many valence electrons, or how many electrons are around hydrogen here? 2, 4, 6. How many, well, we're sharing so that they all have a what? Octet. How many is hydrogen's octet? Yeah, the nearest noble gas is helium, which is 2. You with me? So hydrogen's octet is only 2, so it can only be bonded to 1 atom, period. Good? Okay, step 3. And we'll follow these steps with examples, okay? Okay. Place remaining electrons, these total valence electrons, right? Place the remaining electrons around the most electronegative. Uh-oh, I missed a step. Sorry. I was thinking, hold on a second. All you have to do, guys, is just cut and paste, right? Sorry. I'm sorry, guys. We'll call that step 4. Step 3. place all other atoms besides the central atom around central atom. Sorry. In step 5, if you have any more electrons, place remaining electrons around central atom. We good? Okay, let's do the easiest molecule, easiest compound, the hydrogen molecule. How many valence electrons? You guys ready to go? Should I wait for a minute? Yeah.
Wait,
Oh, you
question,
just,
sorry.
uh-huh.
So this is like a dumb question, but what exactly is the name of these steps that we're trying to find out?
Oh, good. Drawing Lewis structure.
Thank you.
Thank you. All right. So how many valence electrons does hydrogen have? Just has one, because it's in group 1, right? But there's 2 of them, so we have to multiply that by 2 because of this guy right there, yeah? So that's a total of 2 electrons. Okay? Which one's the central atom? Hydrogen or hydrogen? There's not really a central atom, right? They're just bonded to each other. Now, ladies and gents, I'm gonna show you something real quick. There it is. There's hydrogen, right? If we draw the Lewis structure each. But then the way that we draw this is we just bond them together. We don't draw dots. Are we good? So the way we do it is just H with a line in between the 2 H's. How many electrons did we use? Yeah, this single bond right here, this line that we drew between the atoms, that represents 2 electrons. And we used all 2, we can't use any more. We're done. Do both atoms have an octet? Because they have to. Does that one have an octet? Yeah, it has 2. Does that one have an octet? Yeah, it also has 2. So we're good. So double check that. Make sure you have octets. Okay? Try a more difficult one.
Yeah.
NH3, ammonia. This is the stuff used for cleaning, yeah? Okay, what's our first step? Count the valence electrons. How many does nitrogen have? 5. And hydrogen has 1, and there's 3 of them, so we multiply that by 3. That's a total of 8 valence electrons. Yeah, 3 times 1, yeah. 3 plus 5, that's 8. Good? Okay, next step is determine the central atom. What is it in this case? Nitrogen. Well, 2 reasons. It's all by itself. There's only 1. And it's never hydrogen, right? So nitrogen. And then place all other atoms around the central atom. There's 3 hydrogens, so we're going to place 3 of them around it. And again, you can place them on any side, doesn't matter. How many electrons have we used so far? 2, 4, 6, good. Each bond represents 2 electrons. So we take 6 away and we have 2 electrons left. Where do we put them? Around the most electronegative, which is nitrogen, or the central atom. There they go. Now do they all have octets? That one has 8, that one has 2, 2, and 2. We're good. We don't have to draw those circles, guys. Please don't. Okay. We good?
I don't get the octet. How do you, like, what does that mean?
It means, well, go back to the periodic table. These guys have a complete octet. The noble gases and every element wants to be like them, right? Because they're balanced. Because they have 8 valence electrons. Yeah? And so carbon only has 4. It wants 8, so what's it going to do? It's going to share until it has 8. In this case, nitrogen has 5, but it wants 8. So it's shared with these hydrogens. So hydrogen has 2 because it's shared with nitrogen, and nitrogen has 8 because it's shared with 3 hydrogens. These are shared. That means each atom gets to include them as theirs because they're sharing them. Right? Did that answer your question?
Yeah.
Okay. All right. Do you want to try some on this worksheet? Okay, section 1 is just doing simple elements, single elements. Do we need to practice any of those?
Can we just do one?
Yeah. Which one do you want to do on section 1? What?
The SI.
Okay, carbon, C. Okay. How many valence electrons does carbon? This is our first step, right? How many valence electrons? 4. It's not bonded to anything, so we're not going to do the rest of the steps. We're just going to put them around it. 1, 2, 3, 4. Done. Does that make sense? Okay. Anything else on that section?
So I just have a question on like this thing says if this element were to form an ion, what kind of an ion?
Oh, okay, okay. Well, carbon won't form an ion. But what will bromine? It's going to be a 1- charge, right? It's going to be, so bromine looks like this if we draw the Lewis structure. And it has 7 valence electrons. It wants 1 more. And if it were to gain that 1 more, now it's Br1-, or just Br-, right? So the ion would be Br-. It's an anion. Good? That's all that's asking. Good? Yeah, Connor.
So how do you know when it applies to an ion? Does that have to be like just the 7th column, or
When it applies to what?
like how do you know it's -1? Is that when it's in the 7th group type thing?
Uh-huh. But here's the way to think about it. It wants 8. They all want 8, right? Well, except for the ones that want 2, like helium. They want 8. So it has 7 valence electrons. It wants 1 more. If it gains 1 more, it gains 1 more negative, so it becomes -1. If it wanted 2 more, it would gain 2 electrons, it become -2, and so on.
So I'm just curious because you said carbon doesn't get one. Is that because it's kind of in the middle realm?
It is in the middle, yes. Uh-huh.
So is that why it doesn't get an ion?
Is it still missing four?
Whether that's the reason or not, I'm not 100% sure, but that's the way that we see that happens.
Alright, so
I mean,
does that apply, I guess what I'm
Yeah.
trying to get at is, does it apply to anything else, or is there like a way to?
yeah, I would say in group 4, it's going to form covalent compounds, except for the metals in group 4. The metals in group 4 will act like transition metals.
Tin and lead.
Tin and lead, yep. Germanium, or whatever that one is. What is that one?
Germanium?
Yeah, tin and lead will act like transition metals. So we can't find how many valence electrons they have, and I won't ask you that.
So what about like magnesium, for example, would that be +2 or?
That's
would that
right.
be -6?
+2, because it's easier to lose 2 than gain 6.
Gotcha.
Good?
So do we not find elements in nature that are like noble gases? Does that mean, can you find just lead?
Just lead?
Is it usually? So can you find the compounds that aren't like noble gases in nature, or do they form to other things, to other valence? Just hold.
So can we find compounds that aren't noble gas? Sorry.
Yeah, like a noble gas composition, like when you find lead or copper, is it, or lithium, is it still -2, or does it try to?
I think what he's trying to get at is if you can, if, for example, another, like, let's say bromine, can you find bromine in nature with like a -1 charge, or does it always have like another hydrogen attached? Like, does it have to be a full?
Is that what you're asking?
Yeah.
Okay, yeah, it will not be a charged atom until it's going to form a bond. Yes, you just like, so great question. You touch all objects and you never get shocked, right? They're all neutral. Everything's neutral. Even the pure elements, they're all neutral until we're going to do a chemical reaction and these things bond together. And it takes energy to bond them. So yeah, they don't happen by themselves.
What about like?
Great question.
electricity, Like, you know, getting shocked or struck by lightning or you touch it.
That's a physics question. Do you want to talk about it? You can.
Yeah, I would mess around and find out. It's like, you know, I'm just curious. You know.
So, we can talk about that if you want. Does everybody want to talk about that? We can,
How you get
but it's
electrocuted?
physics.
Well, you guys do it, man.
What do you think?
Google it.
No, I can talk to you after class if you want, unless everybody wants it. Okay. No? Okay. Are we good with section 1? Okay, section 2. Let's try some of these. Which ones do you want to try? Which ones look the ickiest? In fact, why don't you try water, guys? Try that one. Draw the Lewis structure for water. And if you got that one, do some of the other ones. If you have questions, let me know and we can go over it.
I think,
Wait.
huh?
No, go ahead.
I was gonna say, so for the H2O, we can do H, the line, and then down.
Well, what's our first step?
Count the layers.
Oh, let's do that first, because that's all that we get to use, right? And then the second step is which one's the central atom? Which one is?
The oxygen.
Oxygen. Then we bind the 2 hydrogens to it. Either side, doesn't matter. And then we count how many electrons we have left, and we keep placing them until they all have octets, and we used only those electrons. That's it. Because if you follow these steps, you're going to get it right every time. If you try to just draw it, you're going to make a mistake if you skip steps or don't count the valence electrons. So, does that make sense? Or what was you asking?
I guess, to be honest, I don't even know what I'm asking, but,
Okay?
so, I just thought that when it's like the hydrogen, when it's, I guess that's only when it's just hydrogen, huh? That's when you do hydrogen in the line.
Yeah, hydrogen can only be bonded to one atom. That's the only one that can only be bonded to one atom. So,
So like oxygen would have 6 valence electrons.
so we got 6 for oxygen, 1 for hydrogen, multiply 2,
So that's 8.
total of 8 valence electrons, good.
So then it would it be O and then 8 around it?
Not yet.
Oh,
We're going to put the hydrogens bonded to it.
okay, that's right.
Kind of slipped on that one. How many electrons have we used so far?
4.
4. That means we have 4 left.
2.
Does hydrogen want any more? So we put them around the most electronegative, 2, 4. Does oxygen have an octet? Yeah. There's 4 around oxygen. Or sorry, 8 around oxygen. Yeah, Carla.
Right, so how, like, why did we use 4? Is, like,
Each bond represents 2 electrons. So one of the electron came from oxygen, and one of them came from hydrogen, on both of them. So if you count just the ones from oxygen, it's 6. If you count just the ones from hydrogen, it's 1. Right? But then when they bond together, they share the ones that they're bonding with.
Oh.
Does that make sense?
Yes, because that's what I got confused about, because I was like oxygen alone, I was like thinking that oxygen that
Yeah, it
alone
only has 6.
So that's why like if we had 4, then it's 8, so it doesn't have, or it's 10, so it doesn't have octave. Does that make sense?
Yeah.
That's why I got lost. But, so basically when we write them down, so we already did the math, right? So there's 8 electrons and we have to place it. And once we start drawing it, we have to assume that each compound doesn't have any electrons. I feel like, does that make sense, kind of what I'm saying?
Assume they don't have any electrons?
Because we're placing the dots. Does that make sense?
Well, so this is not really what happens. But this is just a method that we use to do it correctly. If that makes sense. So, if you want, guys, I don't do it this way because I don't like it. But let me show you another way. We get the electron dot structure for a single element, right? Here's hydrogen. Here's oxygen. Here's hydrogen. Well, these guys share. You follow? So we have 6 for oxygen, 2 for hydrogen, or 1 for hydrogen. Altogether, it's 8 total. And now this oxygen has 2. These hydrogens have 2, and the oxygen has 8. Does that help?
That's
Yeah,
a
but where's
mixed family.
Yeah. We call them polygamist.
Yeah.
No, sorry.
No, it's funny because that's how I remember things, and I start associating it with like crazy things, and then I'm like, okay, it's gonna make sense.
Okay. So we're good then? Or did I not really sum it up? Okay. So we're good with water? Anything else before we move on to something a little bit more complex?
Can you try CO2?
Yeah. Yes. That's more complex. Should we just try on CO2? Let's do it. Okay. So, first step, we count valence electrons, yeah? How many does you guys like this way, okay, or do you want to do the dots? Yeah, let's do both. What one do you want me to do first? Okay, so how many valence electrons does carbon have? 4 valence electrons. What about oxygen? 6, and there's 2 of them, so we have to multiply 2. Any questions on how we counted this? So that's a total of what? 2 times 6 is 12, plus 4 is 16 electrons. Good? Which one's the central atom? Carbon. Well, it's all by itself and it's the least electronegative, so we're good. So we got carbon with 2 oxygens. You don't have to put them to the sides, but I like to keep it symmetrical whenever I can. And that'll make more sense when we talk about geometry next time. Okay? You mean we're doing geometry? Okay. It's not like geometry math class, but okay, a little bit. Okay, how many electrons have we used so far? 4. So we subtract 4 from 16, and we have 12 left. Where do they go? Around the oxygens first. Why? Because it's most electronegative. So if we follow these steps, the first one says put them around the most electronegative element first, and then the last step is placed around the central atom. So why did we do that for this ammonium? Because it's both, really, right? It is the most electronegative, and it is the central atom. So it kind of worked both on that one. So we're going to put them around the oxygens until it has an octet. It already has 2 with this bond, right? So we got 2, 4, 6, 8, 10, 12. We don't have any more. What's the problem? Carbon doesn't have an octet. What are we doing with these electrons? We're sharing them. Well, let's keep sharing until we have octets. Who has extra to share, carbon or oxygen? Oxygen. So let's take 2 from here and share it there. Does that oxygen still have an octet? Each bond represents 2. That's still an octet. So he's okay sharing, right? I say he, it's not a he. Maybe it's a she, I don't know. Okay. And this side over here, let's still don't have an octet, so we take 2 off and share there. So we make a double or a triple bond to create that octet. Good? We won't have anything more than a triple bond. Good? Yeah.
And the reason why we only put 6 dots around oxygen was because that's the max valence electrons that, oh wait, no. Yeah, why don't we like just do 8?
So
Yeah.
now listen. If we draw, let's do this with dots. Okay? And let me show you what happens with dots. Oxygen has like that, right? And we have another oxygen like that. And then we have a carbon. Has 4. You with me? And you could do this. It works. Okay, so we got these guys are going to bond. Then, okay, this guy's going to come over here. This guy's going to come over here. So this is probably really what happens. This guy's going to come over here. This guy's going to come over here. We have another bond, right? Do you see how that works? So oxygen has 1, 2, 3, 4, 5, 6 still on both sides. And carbon has 1, 2, 3, 4. Still has 4. So that's probably what happens. So why don't I do it that way? Because it's messy. And that's why I gave you these steps to... So you can do it that way, though. You can.
Don't look at me.
No, you can. If it clicks in your brain to use the dots, use it, please. That's what's going on. Good?
Thank you.
Yeah, you bet. Thanks for asking. Please ask, always. And maybe I'm just a quirky guy because it just works in my head.
Can we try doing the positives and the negatives? So it's what it goes in negatives. So carbon, oxygen, 3, -2.
Carbon. Oh, yeah. Good. Yeah, we need to do that one still.
Okay.
Yep. Are we good with double and triple bonds, guys? Do this one first. And 2.
Bless you.
We good? How many bonds do we have?
2.
Okay. Let's try it. 3, 2, what is it? 7, 9? Let's work it out. We have 10 electrons. Did you guys all count 10 electrons? How many did we use so far? 2, so we have 8 left. Put them around the nitrogens. 2, 4, 6, 8. We don't have any more. Who's going to share? The nitrogen on the left or the one on the right? On the left, so we're going to take 2 away from here. Does this nitrogen still have an octet? Yeah, he's happy to share. Does this one have an octet? Not yet. So we keep going. Who's going to share? Who has more to share? The one on the left. Do they all have octets now? Yeah. And we only used 10 electrons. And count them to make sure. 2, 4, 6, 8, 10. Yeah. Good. That's it. Triple bond. Good? Okay. So, you're going to make mistakes trying these guys. You will. And you have, right? And that's okay. So, make sure you count the valence electrons. Make sure they all have octets. And when you're done, count the electrons again. Make sure you didn't add too many. Because it's easy. Oh, this just needs 2 more. I'm going to just write them in, right? It's easy to want to do that. Okay? All right. Let's Let's do polyatomic ions, because those are covalent compounds, right? So let's do NH4 plus and NO3 1 minus. Okay, let's do ammonium first. Count the valence electrons. We have 5 for nitrogen, 1 for oxygen or for hydrogen times 4. And that's a total of what? 9. Here's a hint. If you get an odd number, you counted incorrectly. You will never get an odd number of valence electrons. What does this mean? Yeah, it's a plus, but what does that mean? We lost an electron. That's why it's positive. So we have to subtract 1 electron, and now it's 8 electrons. Does that make sense? Okay, so if we draw this, we have 4 hydrogens. How many electrons have we used so far? We used all 8. We're done. They all have octets. Now we have to show that it has a charge. It has a positive 1 charge. So we draw brackets just around the polyatomic ions and include the charge on the right. Good? Okay, now let's do the nitrate. 5 for nitrogen, 6 for oxygen times 3. What does this negative 1 charge mean? 1 more electron, 1 more negative. So we add 1 more. You follow? And so we have 18 plus 5 is 23, 24. Nitrogen's the central, 3 oxygens, 2, 4, 6. We have 18 left. Am I going too fast? 2, 4, 6, 8, 10, 12, 14, 16, 18. We don't have any more. Are we happy?
No.
No, nitrogen only has 6. So we have to take 2 away from one of the oxygens and make a double bond. Does it matter which oxygen we take it away from? Not in this class. Okay? Yeah, doesn't matter. But what I would recommend you do is try to make it look symmetrical. That's going to help you for the next step. Okay? And that's why I did it in the center one. What are we missing? Brackets and the charge. That's it. Questions? Well, you just got to practice, right? We have about 5 minutes left. We can take the time practicing for 5 more minutes, or we can call it good and just make sure you practice later. What do you want to do? Oh, but I'm so tired. It's ready to go home. Should we go home? Okay. Uh-oh.